In quadratic functions and parabola, we first are going to start with the general form. The general form of the quadratic function is f of x equals ax squared plus bx plus c, where a, b, and c are real numbers with a not equal to 0. The graph of the quadratic function is a parabola, and it has a turning point called a vertex. The three key ingredients to determine the graph of a quadratic function is the vertex, whether the parabola opens up or down, and how wide or narrow it is. So if we have a parabola that is upward opening, let's say that our vertex is the point HK. So some coordinate HK is your vertex. You'll notice since this parabola opens up and goes up forever, it has no highest point, but it does have a lowest point, and that is the vertex. The minimum value, they're talking about the y value, the minimum is k. The axis of symmetry is this vertical line that we could draw through the middle of that parabola, and it separates the left and right halves, so that if you were to fold your graph on that dashed line, those sides of the graph would lie on top of each other. This is a vertical line with equation x equals whatever the x part of the vertex is. If our parabola is downward opening, then the axis of symmetry is here again with equation x equals h, if our vertex was the point hk. And the maximum this time, it doesn't have a lowest point because it goes down forever, but it does max out here. It has a maximum value, meaning the y part of k. Further, with the graph of a quadratic function, we know that a parabola is going to open upward or be concave up if a is positive. So if the coefficient of x squared is positive, then it's going to be opening up. And that way the vertex is the minimum point. The parabola opens down if a is negative, and then the vertex is going to be a maximum point. In other words, it's positive. If a is positive, it's happy. If a is negative, then it's going to be sad. So then you can tell if it's going to be a minimum or maximum point. The vertex has an x coordinate equal to negative b over 2a, which comes in pretty handy. The y coordinate can be found just by taking that x part of the vertex and putting it back into the function. In other words, the vertex formula is negative b over 2a, comma, taking that negative b over 2a and putting it back into the function to see what the output is at that x value. The vertical line x equals negative b over 2a is the axis of symmetry. Remember that a complete graph includes particular things. For a quadratic function, it's going to show the vertex, the y-intercept, and the x-intercept, if any. Increasing and decreasing functions. A function f is increasing on an interval f if for any x1 and x2 in the interval, when x2 is bigger than x1, then it's also true that f of x sub 2 is greater than f of x sub 1. So it means as you're reading your graph left to right, x is getting bigger and y is getting bigger as well. That would mean it's increasing. We're decreasing if we have this x sub 2 that is bigger than x sub 1, and f of x sub 2 is smaller than f of x sub 1. So you can see as you go from left to right, the x is increasing, but the y is decreasing. It's getting lower. Graphing a quadratic function. Determine if the parabola opens up or down, the coordinates of the vertex, and if the vertex is a maximum or a minimum, then we'll graph the function. So first we see that a is negative, it's less than 0, so it means our parabola is going to be sad, it opens down. The vertex we first find by the x value being negative b over 2a, so that's the opposite of negative 4, divided by 2 times negative 2. So 4 divided by negative 4 is negative 1. That means that our vertex has an x of negative 1. And if we are to find the y, we simply plug negative 1 back into the function. Simplifying, I get a positive 1 times negative 2 is negative 2. This is going to be a positive 4 and a positive 6. So I have 8. My vertex is at negative 1, 8. Is the vertex a maximum or a minimum? Well, the vertex is going to be the highest point on the parabola since our parabola opens down. So it's going to have a maximum, and the maximum value or the maximum output is 8. We'll go ahead and do a t-table. We want to stay in close to the vertex. The further you get from the vertex, the faster a parabola will grow. So to graph points that are more easily manageable, we'll stay close to the vertex. Put the vertex in the middle of your table and then go a couple of values on either side of that for your x. And we can put this in the calculator if you like. Negative 2 times negative 3 squared. And we're subtracting 4 times negative 3 and then adding 6. We get a 0. So we put in a negative 2. Remember, you can go up, copy that expression, replace the negative 3 with the negative 2, and I get 6. Again, we can copy that expression and replace with 0, and I get a 6. And one more time we can try replacing that function input with 1, and I have and we get a 2 there. But except I didn't want to. Need to put in a 1. Okay, there we go. And we get 0. And you should be able to see the symmetry in the table there. Symmetry in the table, and it's going to show when you graph it. Let's go ahead and draw it out. And we have negative 3, 0, negative 2, 6. So negative 2, 6, negative 1, 8, 0, 6, and 1, 0, and get a nice parabola here. And that's complete graph. We have the the y-intercept, we have the two x-intercepts, and we see the vertex, and we see what's going on after that graph. And we just put the arrows to show that it continues that way. In this example, let's go ahead and determine if this opens up or down. We see A is positive this time, so it's going to be happy. That means this opens up. And then we can find the vertex. The vertex is negative b over 2a. So the opposite of negative 16 is positive 16 divided by 2 times 0.4. So we have 16 divided by 0.8. We put that in the calculator if you like. And gives me 20. Okay, we can go ahead and start our t-table. I know that my vertex is going to have an x of 20, and I put the 20 in for x in the function and simplify, and that will give us our output, the y part of the vertex. So we have 0.4 parentheses 20 squared. We're subtracting 16 times 20, and we're adding 18. We get a negative 142. Now let's go 2 on either side of this. See what happens. I have a go ahead and replace the input. Let's go ahead and start with 18. Replace our input with 18. And I get negative 140.4. Again, copy that expression. Replace your 18 with 19. Simplify, and you get a negative 141.6. And one more time, I'm going to put 21 instead of the 19. And oops, do it in both places. Hit enter too quickly. 21. Enter. So negative 141.6 and 22. And that's negative 140.4 as expected. So we can see the symmetry in our table. Alright, let's go ahead and get a graph going. Then we'll see that we probably will need a little bit more in our table. So we have some larger numbers for x. Let's go by 2's. Since we're going to do a different scale, make sure and show your scale for at least a couple of the tick marks. So we have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30. And on the y-axis we have some larger numbers there as well. So let's maybe go by 20s. So this would be a negative 20 there, negative 40, negative 60, negative 80, negative 100, negative 120, negative 140, negative 160, negative 180, negative 200, and we'll see how we end up here. So I have an 18, negative 140.4, 0.4. And I have a 19, negative 141.6, and then I have 20, negative 142, 21, and 22, those points there. So we're nowhere near the x-axis, and we don't have any points that are on the y-axis, so we need to figure out some of this stuff here. It's easy to find the y-intercept. Just make your x 0. If x is 0, those first two terms go away and you get 18. So here we go. 0, 18 is our y-intercept. And to figure out our x-intercepts, you can factor, you can try completing the square, you can try quadratic formula. Those are all algebraic methods. I'm going to show you on the calculator a way that you can use a new calculating function to get your x-intercept. So go ahead and put your function into the grapher. And let's see, let's set our window. We know that the x part of our vertex is at 20, and we want to show the y-axis. So let's go from negative 2 and then go to maybe 42. And we'll do a zoom fit. That should show your graph really nicely in there. Now what we want to do is find the x-intercepts now. Those are places where the y part is 0, so it's numerically the same as the 0 of the function. So you're going to hit second, calculate the 0. We're finding where the graph has a value, a y value, an output of 0. So let's do the left one first. Okay, we're to the left of the 0 of the x-intercept, so we go ahead and hit enter. And then now it's asking us for the right bound, so we're going to go to the right of the 0. You can see there the y changed from being positive up there to negative down there, so you know that we have crossed over. And go ahead and hit enter one more time, and you'll get this about 1.16. So continuing the t-table, we have a 1.16 and get a 0 for the y. So 1.16, we're about right here. And then let's try it again. We're going to calculate the 0, and we'll go to the right quite a bit. Get closer to the other 0 of the function. There we are. And we'll hit enter. And now go to the right of where you see it crossing and hit enter. And go ahead and hit enter one more time. And we get about 38.8. So 38.8. And that gives us a y of 0. You might have a different readout on yours. It just depends on the approximating algorithms, where you set your left and right bound, your zoom level. All these things go into those approximating algorithms in the calculator. This is just a very, very, very small number. Remember, we were trying to find the 0. It even tells you here. So you can just assume that that's 0, close enough to 0 to be 0. So I have a 38.8. I have to move here. 32, 34, 36, 38, 38.8, so it's almost 39. 0, and just as nicely as you can, graph that parabola as smooth as you can. This is a very wide opening parabola when you use the scale that we did on the graph there. Alright, that's it for that one. For example 2, we are maximizing revenue. Suppose the monthly revenue from the sale of Carlson 42-inch 3D televisions is given by this function r of x equals a negative 0.1 x squared plus 600x, where x is the number of televisions sold. Let's go ahead and write out what each point on this function means. They're using the variable x for our independent variable, and it's the number of televisions sold. And on y, y is our r of x, and it's the monthly revenue. So we're supposed to find first the vertex and axis of symmetry. The vertex can be helpful if we use the vertex formula on this one, since we have fairly large numbers. So we're going to do the opposite of b. Remember, it's negative b over 2a. So the opposite of b divided by 2 times a. So that's going to be 600 divided by 0.2. Go to your home screen. 600 divided by 0.2, and that's 3,000. So I know that the vertex has an x of 3,000, and we want to find the y that goes with that. So negative 0.1 times 3,000 squared plus 600 times 3,000, and that's going to be 900,000. So the vertex is 3,000, 900,000. And the axis of symmetry is simply x equals the x part of the vertex. So x equals 3,000. Part B, determine if the vertex represents a maximum or minimum point. For us to know that, we need to know if the parabola is opening up or down. And it's opening down. It's sad because a is negative. So if it's opening down, then the vertex is going to be the highest point on the graph, or maximum, as a maximum. And we need to interpret the vertex in the context of the application. That means you mention both x and y and talk about what it means in terms of the language that's used in the problem. So this means that if 3,000 TVs are sold, then they reach their maximum revenue of $900,000. We can graph the function. Let's go to y equals negative 0.1 x squared plus 600x. There we go. And we know the vertex has an x of 3,000. So on the window, let's go from -2 so that we can see our y-axis, and go to maybe 6,500. -2 and maybe 6,500 on the y, and do a zoom fit. And there we go. It's a nice graph of the function. It's a complete graph. You see the x intercepts. You see the y-intercept, you see the turning point of the vertex. So for what x values is the function increasing? I'll put this graph in here for you. For what x values is the function increasing or decreasing, and what does it mean in the context of the application? So it's increasing from here to here, right? The x values from 0 to 3,000. So from 0 to 3,000, it's increasing. And that means their revenue is increasing if the sales are between 0 and 3,000 televisions. And it's decreasing from 3,000 to infinity, which, you can keep going this way, it's a positive infinity, if sales are higher than 3,000 TVs. Foreign-born population. Using data from 1900 to 2020, the percent of the U.S. population that was foreign-born can be modeled by the equation y equals 0.0027x squared minus 0.3692x plus 18.9149, where x is the number of years after 1900. So again, let's go ahead and write what each coordinate means. X is the number of years after 1900, and the y is going to be the percent of U.S. Population that's foreign-born. So percent of foreign-born population, specifically in the U.S. Okay, so during what year does the model indicate that the percent was a minimum? So at this point in the course, since we've only done linear equations before this one, that word of minimum is a key word to tell you that we are looking at a vertex problem. It's a quadratic, and we're needing to find the vertex. So we go ahead and can do that with the slope formula. So we're going to have a negative of b over 2a, and that gives me a positive 0.3692 divided by 2 times 0.0027. Let me put that into the calculator. 0.3692 divided by parentheses 2 times 0.0027, close parentheses, and that is means 68 years and then a little bit more. So 68 years after 1900 is 1968 plus a little bit more. That would push us into 1969. So this is about 68.37. So 1969 is the year that the percent was a minimum. And then what is that minimum percent? So we're going to put that number here back into our function and figure out what the y is that goes with that x. Go 0.27 times that number squared minus 0.3692 times that number plus 18.9149. Okay, and that gives us about 6.3%. So in 1969, the percent of U.S. population that was foreign-born was at its minimum at about 6.3%. Example 4 shows how parabolas are used with applications of gravity. We're using this model for the height of the ball to track the height above the ground. So the height above the ground of a ball thrown upward at 64 feet per second from the top of an 80-foot high building is modeled by this equation. S equals 80 plus 64t minus 16t squared. T is our independent variable. It's the number of seconds after balls thrown. And S is going to be the height above the ground. And that's given in feet. So we are to find the t coordinate and s coordinate, the vertex of the graph of this quadratic function. So we can actually put this into the calculator pretty easy. Since we're talking about how many seconds it takes for the ball to hit the ground, we can graph it pretty easy with the calculator since we have that zoom fit function. Let's go ahead and put your function in there. And let's set our window from -1 seconds just so we can see the y-axis, and an x maximum, gosh, let's hope that it hits the ground by 6 seconds after it's thrown up from that building. And let's do a zoom 0, and sure enough you can see where it leaves the launching point at the top of the building, and then see the height above the ground at whatever seconds we have. So we can calculate the maximum here is what we're going to do. We're going to calculate the maximum. And so we go to the left of where we see the maximum. It's asking for the left bound. And then it's asking now for the right bound. So we're going to go to the right of where we see the maximum and hit enter. And then guess. So we'll go ahead and hit enter. And the maximum is at about 2 seconds, 144. So that's the vertex, 144. We've already graphed the function using the window that includes the vertex. Now let me save that for you. And if we want to explain the meaning of the coordinates of the vertex, we need to make sure that we mention both numbers and also what they represent. So this means that at 2 seconds, we reach a maximum height of 144 feet above the ground. Don't just say 144 feet, because then someone who did not do this problem or maybe not as familiar with it might wonder, is that 144 feet above the building or 144 feet above the ground? That would be an 80-foot difference in those answers. So there we go. Vertex form of a quadratic function is simply a different form that these could be given to you, and it's actually a kind of a helpful form because it could be used also as a formula. So when it's written in this way, where a is in front, and then you have x minus some number, quantity squared, so a binomial squared, plus some other number, that's vertex form. For example, if I had y equals negative 2 times x plus 7 quantity squared plus 3, then that would mean our vertex is the number that's being subtracted from x. So what number is being subtracted from x? It's a plus 7, so it must be a negative 7 that was being subtracted from x. If it was x minus negative 7, then that makes it an x plus 7 after simplification inside the parentheses. And the number that's tacked onto the end is the y part of the vertex. So same as usual, this a is the same as if we had y equals ax squared plus bx plus c. That a is going to be the exact same as that a, so the rules from before still hold. If a is positive, it's going to open up. If a is negative, it's going to open down. And then you would have either the minimum or the maximum, respectively. And the axis of symmetry still has the equation of x equals h. In this example, we are minimizing cost. Again, key word is minimizing. At this point in the course, we know that this is going to be a parabola problem. The cost for producing X champion golf hats is this equation. C of x equals 0.2 times the quantity of x minus 40 squared plus 200 in dollars. And we are to find the vertex of the function. It's in that form, vertex form, so we just look at it and know that the x part is 40 and the y part is 200. And is that vertex a maximum or a minimum? Well, this is a positive number, so it's happy. So the vertex is going to be the lowest point on the graph. It's going to be a minimum. So interpret the vertex in the context of the application. This x is the number of golf hats produced, and this y is the cost in dollars. So the vertex means when 20 hats are produced, then the cost is minimized at $200. Okay, so we mentioned both numbers and what they mean. 20 is referring to hats. Actually, it's not 20 hats, it's 40. 40 hats. When 40 hats are produced, the cost is minimized at $200. Now we're going to graph the function using a window that includes the vertex. So we go to the calculator, go to the y equals, put the function in, 0.2 parentheses x minus 40 quantity squared plus 200. There we go. And I know that my vertex is at 40, 200. So let's go ahead and make the window go from -2 so we can see the y-axis clearly. And 40, a next value of 40 gives me to my vertex. Let's go a little past double of that, so maybe 85. And we'll do a zoom fit. And we do get a nice window with everything in it that we need. And they want to know what happens to the function between x equals 0 and the x coordinate of the vertex. So let's save this graph for you. between that x value of 0 and the x value of 40 coming from the vertex, we end up with we always end up with these the cost that is decreasing, and then after that the cost increases. So between x equals 0 and 40, what does it mean? When we produce from 0 to 40 hats, then the cost decreases for each hat. Each hat you produce, it's going to continue to decrease. You can even look at the table here. 0 hats going to cost you $520. So those are, it's talking about your fixed costs for producing. We've got 1 hat, you're going to make $504.02 on your cost, and 2 hats, and so on. Okay. Example 6, Wright Sports Management had monthly maximum profit, $450,000, when it produced and sold 5,500 waist trimmers. Its fixed cost is $155,000. If the profit can be modeled by a quadratic function of x, then the number of waist trimmers produced, that's representing the number of waist trimmers produced and sold each month, then we need to find the quadratic function p of x. So let's use our vertex model that we had. So we can use the vertex point that they handed us. And you see that maximum profit of $450,000 when it produced and sold 5,500 waist trimmers. So the vertex is 5,500 and 450,000 on your y. So we can put that into our function here via x minus 5,500 quantity squared, and adding in 450,000, and we need another point. We need a point to put in for our xy, not the vertex point. The vertex point is hk. We need another point that is not the vertex that we can put in for x and y. Well, they've given me this figure that the fixed cost is $155,000. That means even if they produce zero product, then they're still going to have a cost of $155,000. In terms of a profit, what would that be? Well, this point is if we produced 0 on the number of waist trimmers, then our profit would be a negative $155,000. You lost because that is a cost. So in terms of profit, it's a negative number. So this is an xy point that we can put into our function. We're going to replace the x here with 0. We're going to replace the y with a negative 155,000. Okay. And now we have this equation that we can solve for a. So let's go back here. 5,500 and squaring that. So I get that number a, and if I have a negative 155,000 and I subtract 450,000, then That gives me a negative 605,000. I'm going to divide that by my coefficient of A, and I get a negative 0.02 for A. So that means the quadratic function is y equals the A that I found times the quantity of x minus the x part of the vertex, quantity squared, plus the y part of the vertex. That is your function. In example 7, I'm going to show you something new on your calculator. We have these points that lie on a parabola. Notice we have evenly spaced inputs. Interesting thing is if you take -2 and you subtract the number before it, so -2 minus a -7 is -2 plus 7, which is 5. You take -7, you subtract -2, in other words, -7 plus 2 be -5, and then you take your -2, subtract 13, that's going to be a -15. That's our first differences. And then if we take this and subtract the one before it, it'd be 5 minus a -5, so that's 5 plus 5 is 10. And then -5 minus a -15, or in other words, the -5 plus 15 is a positive 10. You noticed that the second differences are constant. If the first differences were constant, and they're not, but if they had been the same number, then this would have been easily modeled with a linear function. But we find when we take the first difference and then take another difference, the second difference, then that number is constant. So when it can be modeled by a quadratic function, that is when your second differences will be constant. We can go ahead and put this into our stat editor. So enter your values for x from the table, and then your corresponding y values. Okay, double check to make sure you didn't have any errors into entering that information. And then we're going to say stat, calculate. Before, we've been doing a linear regression. Underneath that, you see quadratic regression. That's the one we want. So we're going to do a quadratic regression and make sure that your x is pulling from list 1, your y is pulling from list 2. And if you like, you can store that regression equation, just like we did before. Go ahead and have it calculate, and there is your function. Y equals 5x squared minus 10x minus 2. You can even see it there in your picture. Let's set our window from -2 to 3 so that we can see the data points in this table. So we'll do a zoom fit. There we go. And you can even go to your table. At 0 we have -2, at -1 we have 13, 1 -7, 2 -2. So this function is modeled exactly with this quadratic function. That's it. Go ahead and try your homework and let me know if you need help.